So this is question number 13.2, and in this question it is asked that obtain the binding energy of the nuclei Fe56 and Bi209 in unit of mega electron volt from the following data. The mass of nuclei of Fe56 is 55 point something, and the mass of nuclei of bismuth is 209 is 208 point something, right? So this is the same question as we have done earlier, 13.1. And because we have to calculate that unit at that mass delta m in energy, but not in joule but in mega electron volt, right? So we have to simply do the same thing. We have to just multiply it with 931.5, that delta m we get in atomic mass unit, and we will get the thing directly, the binding energy in mega electron volt. So what is the concept here? Whatever binding energy you have to calculate, you have to calculate in mega electron volt. Mega electron volt you have to calculate, right? So for that, if you have delta m in atomic mass unit, you have to multiply 931.5 here, just to get it in mega electron volt, right? Simple. So this is the thing that you have to do. Okay, so simply for EB of Fe56, you have to just write the delta m, that is mass defect, is 55.934939 in atomic mass unit, and multiply it with 931.5, right? And by solving this, you are going to get 492 mega electron volt, 492 mega electron volt in an answer, right? So this is A. And in B you have to do, that is for bismuth, 209. So here the mass defect is 208.980388 in atomic mass unit. You have to multiply it with 931.5, and the answer you will get in mega electron volt, right? So the answer you are going to get here is 1640 mega electron volt, right? So this is the same thing. You have to just remember the concept that for changing the binding energy into mega electron volt, you have to just multiply this mass defect in atomic mass unit with 931.5, and you are going to get your result, right? Simple.